Today we look at previously are all linear equation and also relative motion. We move in a straight line. Today we look at what happens if we have a normal and tangent or collinear motion. Right? So equation of motion still the same, F equal to ma. So for example, this diagram you see on the screen, these particles move in a curvature motion. The center of the curve is always pointing in, right? So we capture one particle labeled as P. This P assume moving from the below to the top. So you can split into three-dimensional space. Or in 2D, you see the tangent direction. You should able to know what is tangent direction already, right? Tangent direction, which is follow the direction of the particles. Normal always pointing into the center of the curve, correct? So you have normal and tangent, where you learned in your previous chapter 1. And if you deal with the change of z direction, we label as B for normal tangent dimension. So you have the force acting in three directions, tangent, normal, and B. So you have, you know that we are dealing with vector. Again, all direction along T is UT, which is a unit direction, a unit vector direction. Ft, it means it's the magnitude of that vector. Same with the rest. Okay. Which means F equal to ma equation, left hand side you can break into component that you have. In this case, you have P, you have N, and you have B. Left hand side always deal with force. Agree? Right hand side we always deal with ma, but in this case we have ma in tangent direction, ma in normal direction. Okay, so when you deal with chapter 2 question, you always start with all the force equal to ma. Then you go into the diagram, look at the control principal axis you have, break the force into the principal axis. If it's in straight line, then you have x, y, and z, or in Cartesian plane. Or normally when you see curvature motion, you have normal and tangent direction. Okay, now normal tangent direction normally will not be drawn for you, right? So you'll begin, even in this case, you'll begin x, y, z. But straight away, you should transform the x, y, z into normal tangent and b direction. You transform the information into collinear motion dimension. Okay, then you group them together. Tangent, tangent, you get force tangent equal to mass acceleration in tangent. Mass is not vector, mass is the scalar component. Mass don't have direction. Okay, same with the rest. In this case, because the particle move in the paper, on the surface of paper, it do not, means it move in a 2D dimension, it do not move out or do not move top and bottom, it do not move along B axis. So the force in a B will give you acceleration 0. Means there's no change of acceleration in Z direction. Although there's a force there, but equals 0. Okay? Huh? This one. FB is not constant. It's just that it do not move in Z direction. Means that, okay, if you look at FB equals 0, actually it's F equal to MA. So it means that all the force you combine, it still make the object equilibrium. It still make the object stay at that position. So equals 0. And so it means the right hand side is more on the second Newton law dimension, MA, kinetic dimension. Means there's no change of acceleration in Z direction. Or there's no change of velocity in z direction. Okay, yeah. Let's apply what we learned. Same, you determine the banging angle of the racetrack so that the wheel of the racing car will not have to depend upon friction. What does it mean? It means, what is the condition of the racetrack? If you cut the racetrack will have a certain angle. Let's say this is the wheel. You need to find at a certain condition, there is no pressing force on the surface. Means it just stay at that surface without pressing or without flying away from the surface. Okay. Upon friction, to prevent any car from slipping out or slipping down. So this one, when the racetrack have an angle sliding up, so you want to have a state where it's stable at that location, it will not slide up or slide down. Okay. So assume the car have you ignore the size, mass, travel around a curve or radius r with a constant speed v. How do you start this question? You only look at this question. This question is linear equation, linear case, rectilinear motion or curvature motion. Huh? Huh? Curvature motion. Why? They tell you the racetrack with a certain angle. You know racetrack. You know what I mean by racetrack? You watch race car. Race car, they usually, in this kind of setting, they will have a circular motion. The racetrack is in circle, but a big one. So this one, if you view from top, this is your car, but the car is slanted at a certain degree. Okay. So straight away, you draw the body of the diagram, the car. So this box is the body of the car here. So the center of the curve is pointing in, right? The center of the body will, the curve will pointing into the center of the center. So you're seeing N is here. The T is pointing up to outside the screen. B is up and down. So B is important because the statement tell you we don't want the car to slide up or slide down. So the Z is fixed. Right? So when you read question, be careful on the coordinate that you are going to use. Right? So try to think, what actually the axis that are involved in your calculation. Okay. So you draw free body diagram and kinetic diagram. When you come to chapter 2, split your your answer into left hand side and right hand side, or on the top or bottom. Left hand side, you draw free body diagram. So all the force you put inside the diagram. Any body will have mass. So mass will under effect of gravity, you have weight. Right. No friction force. What I mean by no friction force means there's no contact surface, and you don't need to find. But actually, yeah, I just put it there lah. So resultant of the surface with a certain angle. This angle is the angle of the circuit. Okay. Then you know that acceleration go inside there. This is the interpolation, or not interpolation, overlapping of free body diagram and kinetic. There should be another one diagram on the right, but I overlap onto the free body diagram because N is not force. It is a motion, it's a kinetic. Okay, I overlap the diagram. Okay, So once you have this one, so equation of motion, all the force equal to ma. Equation of motion, F equal to ma, but in n direction. You substitute Fn equal to n sine theta equal to ma. A you change to v squared over rho. In b direction, Nico, what is all the force in b direction? You're now looking at boy toilet. What is the FV? W? Hmm? MA in B direction. That's it. What happened to capital N here? You know that you can break into two forces, right? What happened to the where? Complete one minus W plus equal. Okay, NC cos minus W equal 0. Why 0? Why 0? Why your AB is 0? The 0 component deal with forces, Nico? Right hand side deal with what? Huh? Okay, deal with motion. The question tell you what happened to the B component. Does the car leave the surface or not? So equals 0. You still remember just now previous slide I tell you? B equals 0. So in this case, second equation, NC cos theta minus mg equal 0. How many unknown you have there? How many unknown you have there? Can you find NC? Can you find? Huh? Can you find NC from this diagram? Yeah, NC value. Can you find? Cannot. You need to calculate. But is there information for you to find NC? Yes, you are given theta, you are given mass, you are given G. You have passed your statics. So you can find W in terms of NC. Is split into X normal and B. W is your B. So B component equal to B component. NC sine theta equal to W. Can you see it? Nico, can you see it? Okay. So you can take these two equations. What is the definition of tangent? Tangent theta equal to sine theta cos theta. You learn in the mathematics. So you take equation 1 divided equation 2, cancel NC, sine divided by cos, you get tangent. This one you don't have, right? Yeah. Sorry. Sorry, there's one more equation. Sorry, Okay, so you rearrange the second equation. You get NC cos theta equal to mg. You take first one divided by third one. You get tangent theta. This one, you cancel the m, you get v squared divided by g rho. So theta equal to 10 minus 1 v squared g rho. Okay, this is how you find the angle, the weight, Of course, this question do not give you the value. When it comes to test, there will be value for all the dimension, all the component. Okay. Number 5 will be your final exam question standard. So 3 kilogram disc attached to the end of the cord and is swinging. So this one is linear, collinear motion or curlinear motion. Collinear motion, huh? So collinear motion, you need to identify where is your tangent, where is your normal. As you see on the screen, you have two there. One. Okay. And you're given the motion of the platform. And you're given a cord there. The other end of cord is attached to the ball and socket joint located at the center. If the platform rotates rapidly and the disc placed on it and release from rest as shown, means this one rotate and then you drop the green color pellet. So what happened to the green color pellet? It will stick to the surface and start to turn. Correct. Right. Then determine the time it takes the disc to reach a speed greater enough to break the cord. You need to find the force in this cord. Okay. Again, this is a combination from chapter 1 and chapter 2. Chapter 2, we focus on force and acceleration, F equal to ma. All right. You are given maximum tension is 100 Newton. And the coefficient kinetic friction between the disc and platform is 0.1. You're given kinetic friction means you find the normal forces. So you draw free body diagram of the green object D. Where is the axis that you can draw? B pointing up, normal pointing outside or inside? Normal to the right. Where's the tangent? Huh? Outside the screen, huh? So I draw in 3D. Normal this way, tangent this way. Then straight away I input the weight equal to mg pointing down because for chapter 2, you always have gravitational force. Then there's a contact. When there's a contact, I have normal forces. Makes sense? What does this n help you to find friction force? Makes sense? Okay, so you draw a diagram now. My friction force equal to mu n and is pointing this way. Why this way and not that way? Why? Okay, so it's relative, it's relative to the platform. This is the disc. Let's say this is the platform. The platform move this way. So this is the motion. So the surface here, this is the drag friction force. And you know the friction force, if you look at the intersection of the body here, this is the intersection of body. Bottom one is the force going in. This is the surface below. To balance this force, there's a counter forces, friction force for the body on the top. There is a couple forces. That's why the arrow pointing this way. Okay, now this is your final exam standard. You need to use your logic thinking when you do your engineering degree. Okay, so tangent forces, not tangent forces. This is your cable tension, which is T. It's not cable tension, which is the one pointing into the normal direction. Make sense? Okay. Now, this T is the one that we want to find because we want to find the speed that breaks the tension. Now, in your mind map, in your mind thinking, you are now in chapter 2. You are dealing with only one equation, F equal to ma. You only have one force here. F equal to ma. You want to link this force with the motion of this green color object. Okay, so again, you have tangent direction A. I'm overlapping the kinematic diagram on the free body diagram. So you have two directions. Make sense? So I'm going to use F equal to ma. I focus on the normal direction first, then I focus on tangent direction. Again, for nickel, we are now grouping all the female into the female toilet, all the male into the male toilet. Yeah. So we have three directions, tangent, normal, and B. And in this case, B equal to 0. F equal to ma, but FB for B equals 0 because the disc remaining on floating on the position. You do not fly up or do not drop into the or sink into the surface. So for B axis equals 0. Makes sense. So this type of question, remember you have three axes. If you're given the axis, or it tell you the three-dimensional action. Normally, this one will help you to find the missing parameter. You have three equations, you can solve three unknown. Okay? If you forget about the third one, you will be stuck in the normal or tangent direction. Okay, then you start to put all the equation into the equation of motion. F equal to ma in normal direction, you only have tension cable. T positive going in. That's why you get positive T. Right? Then M is 3 kilogram. 3. Okay. M 3 kilogram. This. So M is 3. Again, N you use V square over rho. Again, this equation won't be given. And every time you see circular motion, write this one in your solution. You write A equal to AN, UN plus AT, UT. Then you write what is your AT, what is your AN. Okay. So you substitute the value, you have the R, which is 1 meter. So you get the T equal to 3V. T, you know, maximum. You want to find the maximum speed that can break the cord. So you tension maximum, you put 100. V square, you can find the velocity that break the tension. And you find the positive value. Right? What mean by negative value, Nico? For velocity? Yeah, what does it mean? Where is the direction of spinning? You're not spinning a object in a circular motion. If you get V negative, let's say you get V equal to negative 2 meter per second. What does it mean? Huh? This diagram give you this direction. What? So what does the object will rotate if you get negative? This was rotated in the anti-clockwise, so the object will clockwise. In what direction? Tangent direction. If you get negative, but in this case you get positive lah, because it's going there. Then the next one you continue. You look at tangent direction. What are the force you have in tangent direction? Friction force. Okay, 0.1 ND equal to 3 AT because you have tangent direction, right? And you're dealing with vector. You have two vector, normal direction and tangent direction. You need to find the resultant for the acceleration. Okay. Then B also same. B you have ND, the weight, equal MAB 0 because the object stay in that position. So you find your ND equal to 29 Newton. This one, ND substitute second highlighted, you get your AT. You get your AT, you can get your V. You can get the time it breaks. What is the time it will be breaks? Again, you are rotating in a constant velocity. Constant velocity, not constant. You're rotating in a constant acceleration. So you substitute here. Again, this equation we are looking at tangent direction. Substitute, you get time equal to 5.9 seconds. What is the most challenging part? Is drawing the correct axis. Use simple logic, what happened to the object. And for nickel, you don't want to see you grouping the wrong forces. Okay. Right. Number 6. You have this entertainment. It's a sport ski. You jump from the top. Require the type of force that will be exerted on the skitter and the approximate trajectory. So this skitter here drop on the platform here. So this skitter was in the profile y equal to 1 over 60 x squared minus 60. What equation we have here? Linear, quadratic. This is what? This is quadratic equation. Positive A, what face you have? Smiling face, huh? That's why you get smiling face here. At that particular, your reference is at 60 meter from the A. Your datum is here and not here. So anything go below this line become negative, right? So we are having this equation, y equal to x squared minus 60. You need to determine the normal force of 7 kilogram M is given. Skitter instantly arrive at the end of the jump at point A. So at point A, where is the normal direction? Upwards. Why upwards? Is curve pointing inside the center of curve. So N is pointing upward. Where is the T? Huh? Why like this? Yeah, normal, you know. Tangent. Where is tangent direction? Yes. Normal, tangent. Normal, tangent always 90 degree. Makes sense. Okay. Now, you solve this question. Okay. This is the collinear motion, right? Collinear motion, this question do not give you the rho. Do not give you the radius of the curve. So there is an equation to find the radius, right? That with the single integration, double differentiation, you still remember? There's one equation. We use that one. So we need to differentiate this y one time and second time. Nicole, what is the differential answer for this equation? dy dx, what do you get? Okay, simplify. Huh? What is double differentiation, Nicole? Okay, so dy dx also means slope or gradient. So gradient at A, you substitute here, will be 0, right? So what I mean by 0? It's a straight line. Okay. So yeah, again, it's a collinear motion. You have a normal and tangent direction. So at point A, I'm enlarging the skitter at point A. So you put in normal and tangent direction. Normal pointing up because the curve is curved down. Tangent is 90 degree to the normal. What forces you have in the free body diagram, Nicole? Every time you draw free body diagram for chapter 2, what is the first thing you put? Weight. Then what else? Friction. Does the friction coefficient given? And this and this one is a skating. Normally, what happened to the skating surface? Smooth surface. So we assume, right? Unless the question give you the friction coefficient, does it given? No. Okay. But there is a normal force always. Don't forget normal force in chapter 2. Always have a normal force when the object contact with surface. Don't forget this one. Okay, every year I see mistakes this one. Huh? They will be sure got student forget this one. You forget this one, your weight will equal 0. With the answer, an minus ag equal to m v square over rho. You substitute all the value, na equal to 70, and so on. All right. This one, ft y0, Nico. Why all the force in tangent is 0? And now your tangent positive to the right. Why 0? Again, F equal to ma, left hand side, you're referring to free body diagram, right? There's no force what? There's no force what? In the what direction? What is that direction? There's no force in t direction, that's why 0. 70, 80. Previous example 5 or example 4, your B is 0. Your B direction is 0. But in this case, we show you that there's a possibility where there's a force in t direction is 0. Or in that direction can be 0. Okay? So you solve the equation. You can get your AT is 0, acceleration in t is 0. Recall this equation. I ask you to memorize. You do dy dx just now. Substitute. Inside there, your rho is 30 meter. Substitute inside here. Plus calculator, you get 30. Okay. Substitute, you find your NA. So this one is your vector. You have tangent direction and normal direction. You need to find result. Square this one, a square n component, square t component. You get NA equal to 133. Okay, 133. So NA is V square over rho, 133, and you can find angle.